In this exercise, we're looking at scales. When you look at maps or plans of things in the real world, you will see that they have scales. If you were going to draw a plan of our school, you obviously wouldn't draw it to a 1:1 scale, because what that would mean is your drawing would actually be the size of the physical school. You would use a scale to reduce the size of the drawing. For instance, you might have 1 centimetre equals 1 metre. Now, 1 centimetre on your plan equals 1 metre. That is 100 centimetres, because there is 100 centimetres in 1 metre. Now that they are in the same unit, centimetres, that is a scale that can be written as 1:100 or 1/100. If I was going to have a scale which was 1 centimetre to 100 metres, 1 centimetre equals, there are 100 centimetres in a metre, so 100 times 100 is 10,000. So 1 centimetre would equal 10,000 centimetres, which means that I would have a ratio of 1 is to 10,000, or 1/10,000th. Sometimes scales aren't written in a ratio. Sometimes they will draw the scale on the map, and they might draw something that long, and they tell you that distance is 10 metres. For part A of this example, it asks us to write 1/1000 as a ratio scale. So a ratio, that is 1, the number which is on the top line, to 1000, the number that is on the bottom line. Part B gives us a ratio scale of 1 is to 200 and asks us to write it as a scale factor. That is, write it like a fraction. So we have 1, so the 1 is on the top line, over 200, 200 is on the bottom line. In the second example, it says to us, how wide is the yellow running track on the athletics field shown in question 5? I have put a copy of the athletics field here. So what you do is you get your ruler and you measure the width across the yellow track. That's this distance here. With my ruler, when I measure it, I get 1 centimetre. Now that is 1 centimetre on this drawing. Earlier in question 5, you'd worked out the scale was 1 is to 1000. So we have 1 centimetre is going to equal 1000 centimetres. So the distance is 1000 centimetres. There are 100 centimeters in a meter. So if I divide this number by 100, I get 10. That is 10 meters. The width across the track is 1000 centimeters, which is equal to 10 meters. The third example has a ratio scale. 1 is to 200,000. It says to us, what distance in real life does 1 centimeter on the map represent? So 1 centimeter will be 200,000 centimeters. So let's convert it. We know there are 100 centimeters equaling 1 meter. So if I take my 200,000 and I divide it by 100, I will get 2,000 meters. If I took my meters, I know that 1,000 meters equals 1 kilometer. So if I took my 2,000 and divided it by 1,000, I get 2 kilometers. So what distance in real life does 1 centimeter on the map represent? It is 200,000 centimeters, which is the same as 2,000 meters, which is the same as 2 kilometers. Part B. What distance in real life does 7.5 centimeters represent? Okay, so if 1 centimeter is equal to 200,000 centimeters, I'm going to multiply my 1 by 7.5 to give me 7.5 centimeters. But then I'm also going to multiply my 200,000 by 7.5. That is going to give me 1,500,000 centimeters, which is a lot of centimeters. Using the same conversion as before, if I divide 1,500,000 by 100, that will convert it to meters, which means I cross off the last 2 zeros. I get 15,000 meters. If I want to convert this to kilometers, I divide by 1,000, which means I'm going to cross off the last 3 zeros, which gives me 15 kilometers. For part C, there's a number of ways we can do it. For instance, we worked out earlier that 1 centimeter was equal to 200,000 centimeters. So that 1 centimeter was equal to 2 kilometers. So if I have 60 kilometers and I divide that by 2, I get 30. So what that tells me is that 30 centimeters on my map would equal 60 kilometers.